Welcome to solverfy.
With a mass of 1.67 times 10 power by negative 27 kilograms is being accelerated by a field of 660 newtons per coulomb. And at a certain moment of time, it has a velocity of 1.1 times 10 power by 6 meters per second. So first we have to calculate acceleration of the proton. Acceleration of the proton is generated by the electric field, and it equals to electric force divided by the mass of the proton, which is charge of proton, which equals to the charge of electron times field divided by the mass of the proton. Now let's calculate this number. Charge equals to 1.6 times 10 power by negative 19 coulombs times 660 newtons per coulomb divided by 1.67 times 10 power by negative 27 kilograms. So now we can calculate this acceleration. It equals to 6.32 times 10 power by 10 meters per second squared. So we can leave two decimals because we can leave three significant digits because that's a number in the electric field, but this is just a constant, so we can add more decimals if needed. But anyways, yeah, that's acceleration. Now we have to calculate how long it takes proton to reach the speed. And I presume that we have to calculate this time in microseconds. So due to the fact that the initial velocity is 0, acceleration time simply equals to speed divided by the acceleration of 1.1 times 10 power by 6 meters per second squared divided by 6.3 meters per second divided by 6.32 times 10 power by 10 meters per second squared. It equals to 1.74 times 10 power by negative 5 seconds, which is 17.4 microseconds. And if we round it to two significant digits as required by the velocity, it roughly equals to 17 microseconds. Then, in question C, we have to calculate how the displacement during this acceleration. So the displacement equals to v0 squared, v squared divided by 2a, because the initial velocity is 0. And it equals to 1.1 times 10 power by 6 meters per second squared divided by 2 times 6.32 times 10 power by 10 meters per second squared. Now we can calculate this result. It equals to 9.57 seconds, which is roughly 9.6 seconds. Oh, sorry, it's a displacement, that's why it's in meters. Obviously 9.57 meters, which is 9.6 meters. So that's calculated. And lastly, we have to calculate kinetic energy when a proton reaches the velocity of 1.1 times 10 power 6 meters per second. So this kinetic energy equals to mass proton times squared velocity divided by 2, or 1.67 times 10 power by negative 27 kilograms divided by 2, and multiply by 1.1 times 10 power by 6 meters per second, all squared. Now let's calculate this result. It equals to 1.01 times 10 power by negative 15 joules, which is roughly 1.0 times 10 power by negative 15 joule. So that's the solution of this problem. I hope I helped you. Thank you very much for your attention.